Thanks for your introduction, and thanks organizers for giving me this opportunity to present my recent work about a generalization of the Eulerian polynomial. This is joint work with Professor Jiang Zeng. Sorry. Uh, let's briefly review some of the permutation statistics. And given a permutation, index I is called a descent if the sigma I is more than the sigma I plus 1, and the ascent and a sigma I is smaller than the sigma I plus 1, and the accidence is the I is smaller than its value as the sigma I. So here we use the aberration descent ascent DS ASC accidents EXC denotes the cardinality of the descent number, the ascent number, and ascent number. For example, here the sigma is 54132. His descent number is 3. It's the first position and the second position and the third position, and the ascent number is equals 1 is the 3 position is from 1 to 3, and the accidents is equals to 2 because it's counting the 5 and 4 in the first and second position. And the permutation statistics is set to the Eulerian if it has the same have the same distribution as the descent. And it is well known that the Eulerian polynomial has the three combinatorial interpretation is counted by the descent, ascent, and ascent numbers. And next we record the left to right the maxima and the right to left the maxima. These two permutations are called the Stirling permutation statistic. And here in this example, and sigma equals 271836564, and its left to right maxima is the 2 and 7 and 8, and his right to left maxima is the 4, 5, 6, and 8. Yeah, and in the 1964, Kali's score will consider the following enumerative polynomial. It's generalized the Eulerian polynomial incorporating the two Stirling permutation statistics. And they compute the following generating functions. And there are some special case when alpha equals 0, beta equals y equals 1 is reduced to the classical Eulerian polynomial, and when x equals 1, when x equals y equals 1, and the beta equals 0 is reduced to the Stirling polynomial. Alpha is counting the left to right maxima, and from this generating function, we can derive the exponential generating function of the Stirling polynomial. We can later we can refine the alpha beta Eulerian polynomial. We consider the consecutive three consecutive elements in the permutation, and it can be classified the valley and the peak and the double ascent and the double descent like this. It's clear that the volume number is equal to the peak number minus 1. Let U equals this tuple, and G can consider the following generalized Eulerian polynomial incorporating the two Stirling statistics and compute the generating functions. It looks a little bit complicated, and this generating function is satisfying the following two conditions. So there is our motivation to find a more conceptual approach to this formula. First, notice that this generating function can be rewritten as this following the form. It can be divided into two parts. So remember this generating function. And we record the cycle alpha t Euler polynomial is the classical Euler polynomial. It's counting the accidents, drop, fixed points, and cycle number. And the cycle number is if we write the permutation in the cycle notation, for example, in this example, is this permutation can be factorized into this for cycle. Sorry, the cycle is number cycle number is 4. Is the job is the index I is more than the sigma I. In this sample, it's 4, 6, 8, and the fixed point is just 9. Okay, it's well known. Its generating functions has the following form. It's computed by someone scholars, and the Fota-Schunz-Bakshi is the first one to compute this generating function using the exponential formula, and the Kalis-Scobiler later compute this form using the calculus. And then the Brenton using the symmetry function and the technique of the Pesism also derived this form. And G, we know that from these two generating function, we can derive that we have found this connection formula. Actually, we generalized it with three more variables. We classify the left to right the minima, maxima, and the right to left maxima according to their whether a peak or the double ascent or the double descent. So we introduce is more generalized Eulerian polynomials and we with the FGT and we find the following connection formulas. So with the generative with the connecting formula and the known generating function, we can derive the exponential generating functions and the continued fractions of the left hand side of the generalized unit polynomial. There are two special cases, is FGT equals 1, and another one is f equals 0 is reduced to the binomial Stirling-Eulerian polynomial. So without the Stirling statistics, the binomial Eulerian polynomial original from the positive goal of the work on the generalized pyramidal hadron, and they prove that this polynomial as each polynomial of the Durance tetrahedron and prove the following combinatorial interpretation: a tutor of x is counting the permutation in Mn, and with the Mn is the set of the permutation, the letter N is the first descent. So we can from the definition, we can see that it's equivalent to the L max peak equals 0. So the first, which proves that gives the lemma is to factorize the AN cycle to the more variables. This proof, we use the cyclic value hopping, where the CPK, CDA, and CDD, CDA as analog, cyclic analog as the peak double ascent value in the linear permutation statistics. So the connection formula can be proved by this connection formula and the two variants of Folta's fundamental transformation. So with this two connection formula, we let mu u equals to x equals x1, 0, x plus 1. We can derive this two form. So it's the form And from that, uh, we can also setting the x equals to x1, x plus 1, 0, or u is 1, 1xy, and x plus 1 over 2. So this 2 mil is related to cyclic double descent and cyclic peak, respectively. So from this form, we can derive this look like the gamma positive expression. So it's a polynomial is gamma positive if can be expanded in the xi and xi 1 plus xin minus 2i. If the gamma I is non-negative, we call this polynomial is gamma positivity. The gamma positivity is implies to symmetries and unimodality. So from these two cases, we can derive the two gamma positivities from the Eulerian numbers and the binomial Eulerian numbers. Gamma positivity is here. And we notice that the gamma coefficients of the ANXT, which he says the first values, we notice that each column G can be divided by the R2G. So what's the combinatorial interpretation? Prove it. So we let this is form, and we can interpretation is using the André permutations and using the X factorization. And so in the example, in sigma, if we consider the 3 factorizations, and we notice that the both sides the maximal consecutive element who's bigger than the 3, and for the rest elements we denote by the mu and v. So the André permutation of two cans can be divided using the X factorization. And it is well known that the number of the André permutation of both sides is equal to the En is Euler numbers. Is the example. Using these two permutation statistics, André permutation and the cycle André permutations. We prove this that using for A, we're using the exponential function, and from the A and the B, we derive a backtraction from the cycle André permutation to the André permutation, and also a backtraction from the two Boscan André permutations. This permutation also used by the Huang, called the web permutation, gave a interpretation between the transmatrix between speech and SR web space of the introducible S2 representations. And the second authentication is defined by using the André permutation. Is similarly. And next we can consider the case Q analog. We first notice that this generative function can be rewritten as the rational generative functions, and we consider the derivative is generalized the classical derivative with the following notations, and we consider that this example, and we find that using the operator x beta delta x and x minus beta, and we derive the numerators. So what's the combinatorial interpretation of the numerators? So we find it. It's called we introduced a mixed alpha beta major index is defined by this, where the major is the sum of the index of I is the descent position. So we derive this position, and this polynomial EK alpha beta Q And also appeared in another Zavahis golden work as the special case, the remix Euler polynomials, and we proved this using the introduction. So there are some two special cases, the Khalees and the Butler, when alpha equals 0, beta equals 1, and alpha equals 0. And the Butler's result is the Q analog Savage result 1 over K Euler polynomial. So we list some of the open problems. Is there a bijective proof for our Q identities? So another one, a second one, how can we put our formula? I mean the Khalees type using the p-partition, or the p-partition can be used to prove some of the Khalees rational function with the Stirling statistics. And the third one, the when alpha equals 0, Butler obtained this polynomial from the cycle counting Q hit numbers, so the Q log series. So can we extend our theorems for the permutation to Rook configuration? That's all. Thank you.